Hello friends, now that we have known how to detail the beams, we'll see how to detail the stirrups of the beams. Okay, the process for detailing the stirrups of the beam is pretty much similar to that of the columns. Okay, so let's first see the shear reinforcement. Okay, so for that let's go to display design info and we go to shear reinforcing and click on OK. Here you can see that the stirrup requirement value is higher at the edge and is lower at the mid portion. This is because the shear force is higher at the edge and lower at the mid. Okay, I'll show you the shear force diagram in a while. Okay, so if I show you shear force diagram, it will be gone and it will take some time. Okay, all right, so 0.931, 0.468, and if you right click on it and if you go to summary, you can see that 0.477 that is presented over here, it's actually the ASV by S value. Okay, so same is for the 0.931, and we'll use the similar method here also. Okay, so let's delete these everything, right? Let's take bar size and let's take as spacing. Okay, so let's calculate ASV, and after that we'll calculate AS, right? Okay, so bar size will take as 8 mm diameter bar, so that will be fine, and ASV is equal to 2-legged, so 2 times into shift 3.1416 divided by 4, right? Pi by 4 into this, again into this, so 8 square. So the 2 has been multiplied because it's a 2-legged stirrup, and in 2-legged stirrup, 2 legs of the stirrup are responsible for controlling the shear force, right? So we hit enter and we get 100.5312 mm square, and the S we get as, so we got the value as let's see 0.931, and let's divide this by 0.931, and we get the spacing as 107.98 mm. And at the mid, what we get, we divide this value by what is the 0.468. So it, okay, so what is that? So division, right? Okay, so it's 214.81. Okay, so we can vary our spacing up to 214.81 mm, right? And at the edge we can vary up to 107.98 mm. So let's see the detailed diagram, and this is the similar diagram. As you can see that the vertical lines represent the shear stirrups, and what we do is that, suppose that depth of the beam is D, so here the depth of the beam is 600 mm, and up to a distance of 2D, that is up to a distance of 600 into 2, that is 1200 mm. From the face of this column, what we do, we place the rebars at closer spacing, that is at 107 mm, that we just got from here. Okay, so for easiness, we don't place the stirrups at 107 mm, we place them at 100 mm, right? Okay, so we can put the spacing lower than this value, not greater than it, right? So what we do, up to a distance of 600 into 2, so suppose that our beam is 600 mm, right? So from the face of the beam we measure 2D, that is 2 into 600, that is 1200 mm, and up to that distance, suppose that it's up to here, right? And up to that distance we place the stirrups at 100 mm center to center. And same we go for this edge as well. We take 2D from here, so 2D, that is 1200 from here, suppose it's up to this point, and these stirrups we place at 100 mm center to center, right? And at the mid, what we do, we place the stirrups at 150 or 200 mm center to center. We can vary up to, I think 200 mm, right? So we place at 150 mm or 200 mm, and to be on the safer side, we place the stirrups at the mid portion at 150 mm center to center. Okay, so this is how we detail the stirrups of the beams. Hope this video was helpful. Thank you for watching.